Right now, you are sitting on a rock. A spinning, hurtling rock, barreling through space at 107,000 kilometers per hour. And you have absolutely no idea how small that rock actually is. Most people think they understand the universe. They've seen the pictures. They've heard the words, billions of galaxies, light years away, infinite cosmos. But hearing those words and truly feeling them in your gut? That's something else entirely. So let's fix that right now. Because by the end of this video, the way you look at the night sky and yourself will never be the same again. Let's start small. Let's start at home. Earth to the moon, this is Earth. Everything you've ever known, every person you've ever loved, every war ever fought, every song ever written, all of it exists on a sphere just 12,742 kilometers wide. Now look up. The moon is 384,000 kilometers away. That sounds like a lot, right? Here's a gut punch comparison. If you drove to the moon in a car at highway speed 100 km/h, it would take you over 160 days. Non-stop, no sleep, just driving. And that's just to reach our closest neighbor in space. From the moon, Earth looks like a tiny marble of blue and white, suspended in absolute darkness. That fragile sphere holds every human being who has ever drawn a breath. Earth to the sun now, let's zoom out further. Our sun sits about 150 million kilometers away, what astronomers call 1 astronomical unit, or 1 AU. That's the standard ruler for measuring distances inside our solar system. Light, the fastest thing in the universe, takes 8 minutes and 20 seconds to cross that distance. But you, boarding a commercial jet at 900 km/h, you'd arrive at the sun in roughly 19 years. Pack a lot of snacks. And yet, from that unimaginable distance, the sun delivers enough energy to power all life on Earth. Every blade of grass, every ocean wave, every heartbeat. All powered by a star, we could fit 1 million Earths inside from 150 million kilometers away. Mars, humanity's next dream Mars, our red neighbor, sits anywhere between 54 million and 401 million kilometers from us, depending on where both planets are in their orbits. The range alone tells you something profound about how dynamic and chaotic our solar system really is. At jet speed, getting to Mars could take over 50 years. Every rover, every probe we've ever sent, they don't just travel far. They travel through constantly shifting orbital mechanics, launching during precise windows that open for just weeks at a time. And we want to send humans there. Let that sink in. If this is already blowing your mind, smash that like button. Because we haven't even left the solar system yet. It gets so much bigger from here. Subscribe if you want to understand the cosmos like you never have before. Neptune and the edge of home Neptune, the farthest official planet in our solar system, sits about 4.5 billion kilometers from Earth. Sunlight racing at 300,000 kilometers per second takes over 4 hours to reach it. And in 1977, humanity launched something extraordinary. Voyager 1. A spacecraft smaller than a car, sent on a one-way journey into the unknown. Over 4 decades later, Voyager 1 has traveled more than 22 billion kilometers from Earth. It is the farthest human-made object in existence. In 1990, at the urging of astronomer Carl Sagan, the spacecraft turned its camera back toward home one final time. The resulting image showed Earth as a barely visible pinprick of light, what Sagan famously called the pale blue dot. Everything humanity has ever been or done reduced to a fraction of a single pixel. That image should be mandatory viewing for every human being alive. The Oort cloud, the final frontier of home, at the very edge of our solar system, lies a place called the Oort cloud, a vast theoretical shell of icy objects stretching up to 100,000 AU from the Sun. That's approximately 1.9 light years away. This is where our Sun's gravitational grip finally loosens. Beyond it, interstellar space. The true void. We have never sent anything there. We likely won't in any of our lifetimes. And yet it's still considered part of our solar system. Alpha Centauri, the nearest star step outside the solar system, and the distances stop making human sense entirely. The closest star system to our Sun is Alpha Centauri, roughly 4.4 light-years away. That means light itself, something traveling at 300,000 kilometers per second, takes 4 years to make that journey. Voyager 1, currently the fastest human-made object, travels at about 17 kilometers per second. At that speed, it would take over 70,000 years to reach Alpha Centauri. 70,000 years. Our entire recorded human history is about 5,000 years old. We would need to relive that history 14 times over just to reach the nearest star. And that star is practically our next-door neighbor in cosmic terms. The Milky Way, our island in space, our galaxy, the Milky Way, spans roughly 100,000 light-years from end to end and contains hundreds of billions of stars, each one potentially hosting its own worlds, its own moons, its own potential for life. Within this galaxy, there's a tiny bubble about 100 light-years across called the human radio bubble. This is the maximum distance our radio and television signals have traveled since we started broadcasting. Every signal we've ever sent into space, every episode of television, every radio transmission has only reached this tiny sphere. Beyond it, as far as the universe is concerned, humanity doesn't exist yet. Our signals haven't arrived. We are invisible to the vast majority of our own galaxy. The local group, Virgo Supercluster, and Delanietia now zoom out further. The Milky Way is just one of more than 50 galaxies in our local group, spread across roughly 10 million light-years. Light from one side of our galactic neighborhood takes 10 million years to reach the other. Zoom out more. Our local group is a tiny member of the Virgo Supercluster, a structure spanning about 110 million light-years, home to thousands of galaxies. Zoom out even more. The Virgo Supercluster itself is just one tendril of the Laniidea Supercluster, a name meaning immense heaven in Hawaiian. Laniidea stretches over 500 million light-years and contains the equivalent mass of 100 million billion suns. At the gravitational heart of Laniidea sits something called the Great Attractor, a mysterious region of space pulling thousands of galaxies, including ours, toward it at extraordinary speed. We don't fully understand it. We can barely observe it. It just pulls. And our Milky Way? In Laniidea, it's less than a grain of sand on a beach that stretches to the horizon. The observable universe, and what lies beyond, finally, we reach the edge of everything we can see. The observable universe. It spans about 93 billion light-years in diameter. But the universe is only 13.8 billion years old, so how can it be so large? Because space itself has been expanding since the Big Bang. The galaxies at the edge of our observational limit have been carried so far away by this expansion that they now sit beyond 46 billion light-years in every direction, even though their light set out 13.8 billion years ago. And beyond the observable universe? We don't know. Some regions of space are expanding away from us faster than light itself can travel, meaning they are permanently beyond our reach. We will never see them, never know what's there. The universe may be infinite. We may be looking at a tiny bubble inside something so vast it has no name, no edge, and no end. Here's the thought I want to leave you with. Every empire that ever rose and fell, every ocean that was ever crossed, every discovery, every heartbreak, every extraordinary human moment, it all happened on that pale blue dot. A pixel. In a galaxy of 400 billion stars. In a universe of 2 trillion galaxies. And we still got up this morning and worried about traffic. Maybe the universe isn't here to make us feel small. Maybe it's here to remind us that what we do with this tiny, fleeting existence genuinely matters precisely because of how rare and improbable it all is. If this changed how you see the sky tonight, Share it with someone who needs their mind blown. Like, subscribe, and I'll see you in the next one where we go even deeper into the cosmos. The universe isn't done surprising us, and neither are we.